Alright, so we'll be looking at the derivative of sine x. So let's just prove that. So let f of x equal to sine of x. Now we'll be using first principles, so if you haven't seen that video, have a look at the top right, there'll be a link to that video. Anyways, from first principles we know that it is the limit as h approaches 0 of f of x plus h minus f of x divided by h. And that is the first principle rule that we learned in the previous video. Alright, now substituting sine x into that, we get the limit as h approaches 0 of sine x plus h minus sine x divided by h. Now I want to expand sine x plus h, so I have to use a rule, and that is the compound angular formula. And what this says is that sine x plus h, right, that equals to sine x cos h plus sine h cos x. Okay, that basically makes it easier for us to factorize later on. Alright, so that's equal to limit as h approaches 0 of sine x cos x plus sine h cos x minus sine x, all divided by h. Alright, now we can group the sine x together. So let's take the sine x cos h and the sine x. And that's basically limit h approaches 0, sine x times cos h minus 1 plus sine h times cos x, all divided by h. Alright, now this is a limit, so we can split this into two limits, and that is a property of limits, so we can do that. So let's split that into two limits here, times sine h divided by h, and that's by the limit rule. Right, so now we have to evaluate this. Now before that, please make sure that you like and subscribe to this channel, and it really does. If you really like this video, please subscribe for more. Alright, so let's start with this part, so this limit. Alright, so aside, so the limit as h approaches 0 of cos x sine h divided by h. So let's focus on this one first. Now, obviously the cos x can be brought out the front because it doesn't contain the variable h. So we then have the limit as h approaches 0 of sine h divided by h. Now, if I draw a sine graph, so this is a sine graph. Now what do you notice is that for very, very small values of h, sine h is approximately equal to h. Okay, and we'll see why. So h, sine h is approximately equal to h. And let's see why. So if I take a microscopic view of that bit there, the sine graph looks like a linear graph. Okay, and that's why for very, very small values of h, we can then say that sine h is about equal to h. And therefore it is cos x times, and that limit just goes to 1, so just cos of x. Alright, so that's the easy one. Let's go to the other limit. So this is the bigger limit. Alright, so aside the limit as h approaches 0 of sine x cos h minus 1 divided by h. Alright, so and obviously we can bring the sine x to the front because it doesn't contain the variable h. So just rewriting that again. Alright, now we can do the exact same thing, but note that if I draw my cosine graph here, as h approaches 0, so as h gets really, really small, cos of h approaches 1. Okay, and what basically results is this limit will get 1 minus 1 divided by a very small number, which we will get 0 divided by 0. And of course we can't evaluate this because it is undefined. So we had to find a different way to approach this. So we can rewrite this in a way. So we can times both sides by cos of h plus 1. Okay, so long as they are equal to 1, that's okay. It's just a way we can manipulate stuff. So that's equal to limit h approaches 0 of cos h minus 1, and we multiply both sides by cos of h plus 1. So let's get rid of this, right? So cos of h plus 1 divided by cos of h plus 1. And that's some manipulation there. So that's equal to sine of x times the limit of h approaches 0. Now obviously we can split this into two limits as well because it's multiplication as well. So anyways, I'll expand this. So cos square h minus 1, and by using trig identities, we know that sine squared x plus cos squared x equals to 1. Rearranging that to get cos squared x minus 1, that would equal to minus sine squared x. Alright, and therefore we can rewrite this as sine x, the limit as h approaches 0 of minus sine x squared, sine squared x, h times cos h plus 1. Alright, now we can split this into two limits as well. So limits h approaches 0 of sine h divided by h times negative sine h divided by cos of h plus 1. Now this sine h divided by h, we have done this before. If you look back, so over here, the limit of that is 1, right? So let's put that in there. So we have sine x times 1 times the limit as h approaches 0 of negative sine h divided by cos of h plus 1. Alright, so now we need to evaluate it. So we have a sine graph and a cosine graph. So as h approaches 0 or gets smaller, sine of h approaches 0, right? So from the graph above, and cos of h, it approaches 1. And by putting in those values, I get sine x times 1 times 0 divided by 2. And obviously that gives you 0. Therefore that limit is 0. Alright, so now we have all the ingredients. Let's put it back into our initial expression here. And yeah, and that derivative, so basically f dash of x, so the derivative of sine x, f dash of x, that is equal to 0 plus cos of x. Alright, so therefore the derivative of sine x is cos of x. I hope you learned something from this video. Please like and subscribe to this channel. Thank you.